So I had to zoom in a little bit to see the cube, but let's see if we can. Cats are going through the Zoom set. Let's see if I rotate this. Maybe if I put my finger here and spin it like you were doing. Do you think the cube shows up on camera?
Yes.
Can you see the cube in there as I spin it around?
So the cube is these. This is the top face, this is the bottom, and these here are the lines connecting.
Okay. And now while we're spinning it up here, around a point, we said if we spun it so that one edge rotated over to the other edge, we got to the same dodecahedron, right?
Yeah.
So I get to the same dodecahedron. Do I have the same cube?
I don't think you do.
Okay.
So you rotate it. Well, actually you might, because if you look at just fix this face,
Okay.
this vertex is always on like kind of the right side.
All right.
If you do it here, it's still on the right side, and then you're back to the original face.
Interesting. Okay. So
I
let's
think you
see.
always have the same cube.
So if I spin it, you think I'm back to the same cube.
Yeah.
Interesting. So the threefold symmetry might keep the cube the same. How interesting is that?
It's pretty cool.
What about the fivefold
To
symmetry?
around the face.
Rotating it around the face.
Well, this will not keep it the same because there's a vertex planted through here and it's not exactly through the middle, so it won't stay the same.
Okay.
So if I like put it here, this edge, and here there's kind of the vertex in it,
Okay.
so they're not the same.
All right. So sometimes it looked like threefold symmetry actually did keep the cube the same.
Yeah, but fivefold symmetry doesn't.
Fivefold symmetry doesn't seem to keep it the same. What about the edge flip?
Twofold, well,
Here, I'll put it like this. So, does flipping the edge 180 degrees keep the cube the same?
well, so it's here. It's on kind of the bottom.
Uh-huh.
If you flip it, it's on.
Okay.
So if you flip it, it's on the top now, bottom. Oh,
When I do that flip, is the cube the same?
I don't think it's the same because it rotates from this vertex rotates from the bottom to the top.
Okay. Look at just the cube, though. Look at just that cube.
So the cube actually stays the same.
The cube does seem to stay the same on the vertices.
Yeah.
So now the question is, for all the threefold symmetry, does the cube stay the same? So let's look. So we've got pointing down here, and so parallel with the sides.
Oh no. It's kind of tilted over here.
Oh, now it's tilted.
And now it's tilted away.
Now it's tilted away.
Yeah.
And now kind of parallel to the side. So we found a case where it did seem to stay the same.
Yep.
Is that this case?
Yeah. So it works for some cases. It works where I think the cube's vertices and the pentagon, the cube's vertices and the dodecahedron's vertices touch right here.
And sometimes it doesn't maintain the symmetry.
Yeah.
The interesting thing, though, is that when you look at the face symmetry here,
Yeah.
you can see that we always have a cube in the shape, but it's always a different cube.
Yeah.
So that means there's 5 cubes inside of a dodecahedron,
Cool.
if you can believe that. And now we're going to do a challenging problem where we look at how the cube's symmetries affect the dodecahedron. Okay?
Okay.